Hey everybody, this is the first lesson in polar coordinates and graphs. So the first thing we need to learn is what is a polar coordinate? What is polar? What do polar coordinates look like? So rectangular coordinates are based on an x-axis and a y-axis that make a 90-degree angle to each other. And we use x coordinates that tell us how far right or left to go, y coordinates that tell us how far up or down to go. So we can use those two numbers to describe any point on the plane. Parametric still uses x and y along with the third parameter of usually time to describe motion, but still using an xy coordinate system kind of orientation. Polar, totally different. Polar is based on circles, and it's based on the distance from the origin, and that distance from the origin makes the radius of a circle. So you still use two numbers, but the first number is the radius of the circle that the point would go through, which is basically how far it is from the origin, and the other is the angle that the point is at from the origin. We're still using the same orientation that you're going to be familiar with from trig when we did the unit circle. Zero is still on the positive x-axis, and angles still go counterclockwise. So to give you some reference, just think like unit circle, except instead of all the points being 1 unit from the origin, like a unit circle, these can be further away from the origin. So the way that I would describe this point A, it is on a circle that has a radius of 3. It's 3 units from the origin, and it is at a 30-degree angle. So I could call it 3, 30 if I wanted to use degrees, or 3, pi over 6 if I wanted to measure in radians. This point B is pi, wrong number first, is on a circle that is 2 units from the origin, has a radius of 2, and it is pi radians for the angle. So you're measuring things in terms of distance from one fixed point and angle from one fixed point. So all of those are different ways that you could write this. There are other options too, though, because we could also go like a negative direction. So we know in trig we had positive angles and negative angles. So like this point C, I could name it 5, that would be 5 pi over 4. But I could also name it 5, negative 3 pi over 4. The point is in the same spot. The only difference is what direction did I take to get there? Did I start at the origin and go clockwise, or did I start at the origin and go counterclockwise? So we can have positive angles, we can have negative angles. We can also have, one thing that's kind of weird to think about is we can have a positive radius and a negative radius. So this point B, it is 2 units from the origin, and it is at an angle of pi radians. I could also, though, say that that is negative 2 units at an angle of 0 radians. So the negative radius is sometimes kind of weird to think about, but it's basically saying it's 2 units in the opposite direction of 0 degrees. So point A up here could be positive 3, pi over 6, or it could also be labeled as negative 3, 7 pi over 6. Sorry, messed up my angle there. So it's 3 units in the opposite direction of 7 pi over 6. So lots of options for how you label these angles or describe these, or label these points or describe these points. So one of the things you're going to be expected to do is, again, switch between rectangular and polar, just like you switch between rectangular and parametric. So we've got to have like some reference. I've got to have some way of turning x's and y's into r's and thetas. So if we look at a right triangle, we know from trig that cosine of theta is adjacent over hypotenuse. Well, the adjacent, if we're talking about an xy orientation, the adjacent is the x and the hypotenuse is the r. So it's true that cosine theta equals x over r. Can I solve that for x? Well, sure, just multiply both sides by r. So the x coordinate, if we want to switch to rectangular, is equal to whatever the radius is times the cosine of whatever the angle is. And you can do the same kind of thing with y. Sine theta is opposite over hypotenuse. So if you multiply both sides by r, then the y coordinate in rectangular is equal to r times sine theta in polar. So when you're converting these, and I'm not going to talk about all of them, if I give you an x and I give you, if I give you a radius and I give you theta, so the radius is 2 root 3 and the angle is pi over 6. The x coordinate is going to be the radius times cosine of the angle. And the y coordinate is going to be radius times sine of the angle. And then use your unit circle numbers to simplify it. So cosine pi over 6 is square root of 3 over 2. So 2 square root of 3, I'll write that out real quick. 2 square root of 3 times square root of 3 over 2. Well, the 2's cancel out. And square root of 3 times square root of 3 is square root of 9, which is just plain old 3. So that point on a polar coordinate system would have an x coordinate of 3 on a rectangular system. And then when you do the same thing with the y, you get 2 root 3 times a half. So that's just simplifies to square root of 3. So if I found a point that was at a 30-degree angle from the origin and 2 square root of 3 units from the origin, it would have an x coordinate of 3 and a y coordinate of square root of 3. So those 2 points are the exact same point, just 2 different ways of describing their position. So that's what happens with all of those. And then what if we need to go backwards? Like what if I give you rectangular and I want you to turn them into polar? So r, here it is. So back to what we know about x's, y's, and r's. What do I know about x's and y's? What do I know about x and y that has some relationship to r? Well, x and y are like the sides of a triangle and r is the hypotenuse. So isn't there some formula named after some Greek guy that we know about the sides of a right triangle? Well, yeah, x squared plus y squared equals r squared. So if I tell you the x and y coordinate, I'm basically telling you the legs of a triangle, and r is the hypotenuse. Okay, so what about the angle then? What can I do to relate the angle to the x and the y? Well, the angle is opposite from the y and it's adjacent to the x. Oh, opposite over adjacent, that's tangent. So when you guys are converting rectangular to polar, x squared, Pythagorean theorem, gives you r, and the tangent of theta is going to be y over x, so theta is going to be the inverse tangent of y over x. So does that mean you grab your calculator? Well, no, probably not. So this one, for example, if I do a squared plus b squared equals c squared, I get 9 plus 9, that's 18. Square root of 18, that's really the same as the square root of 9 times 2. And the square root of 9 is 3, and you can't do the square root of 2, so there's your radius. And then, okay, what about the angle? So I know how far to go. Now what direction do I go? One thing to watch out for on these is what quadrant are you in? Because there are 2 angles that have a tangent of, well, any number you can think of for a tangent. You've got 2 different angles that have that. So the point 3, -3 is in quadrant 4. So I'm going to need an angle that's in quadrant 4. So I'm looking for an angle between 3 pi over 2 and 2 pi. So if I do tangent theta equals y over x, y over x, negative 3 over 3, that reduces to negative 1. So, okay, back to our unit circle. What angle on the unit circle has a tangent of, what angle, more specific, what angle on the unit circle in quadrant 4 has a tangent of negative 1? Well, that would be 7 pi over 4. So here are your polar coordinates. The distance is 3 root 2 at an angle of 7 pi over 4. This point, the math is the same, but on this one, 0, negative 2, that's a point that's going to be on the y-axis. So I can find my radius using the Pythagorean theorem. I can do inverse tangent, although I know that point is going to be on the negative y-axis. So inverse tangent of negative 2 over 0, that's undefined. So where do I find angles that have a tangent that's undefined? Also on the negative y-axis, well, 3 pi over 2. And then this last one, same thing, Pythagorean theorem. So we have a radius of 8. Inverse tangent, when I simplify that, I get negative square root of 3. So what angle on the unit circle in quadrant 2, because x is negative and y is positive, has a tangent of negative square root of 3 over 1? So if you're like me, maybe you don't remember tangent as well as you remember the others. So I do remember, though, that tangent is y over x. So I need something on the unit circle that has square root of 3 for a y coordinate and 1 for an x coordinate. Oh, that's way up at the top. That's 2 pi over 3. So there are your radius and your angle. And, okay, this one, and then I'm going to stop this video and I'll do the rest of this in another one. So convert rectangular to polar. What do you do when it has an equation? Well, you use the same identities. Y is equal to r sine theta and x is equal to r cosine theta. So this says y equals. Well, scratch that and replace it with that. So that tells me r sine theta equals 6. So can I solve that for r? Well, yeah, just divide by sine theta. And that's what an equation looks like in polar form. So it's not just polar coordinates. It's an equation that has r and theta in it. And usually you solve it for r, just like with equations. If we can, we usually solve for y. Same thing here. X, forget that. Put r cosine theta. Y, forget that. Put r sine theta. And then I want an equation that has r equals. So, I don't know what happened to my screen there. I want an equation that has r equals. So I can distribute the 4 and distribute the negative 2. So that would give me 4r cosine minus 2r sine. I want an r equals. I want to get r by itself. So I factored out an r. Well, I added the 1 to both sides also. But I factored out an r. And then once I factored out an r, now I can divide by all of that stuff that's with the r. So there we've got r all by itself. On this one, it's the same thing. This one looks a little different. R sine theta in place of the y, r cosine theta in place of the x. This one looks a little different because when you square this, you get r squared cosine squared. So I squared that, and then I also subtracted all of this from both sides. So I end up with r sine theta minus 4r squared cosine squared. I need r by itself, but that's a problem because I've got an r and an r squared. So what do I do with that? Well, I've got an equation that equals 0, and I see something they have in common, so I could factor it. So if I factor out an r, then that gives me r equals 0, and it gives me all of this equals 0. Well, r equals 0 would be a radius of 0. That's like, if it's 0 units from the origin, then it's just the origin. So r equals 0 doesn't make any sense. If we solve the other one for r, subtract the sign, divide by negative 4 cosine squared, and then you have a negative over a negative, which is a positive. How do you work backwards? Well, it's pretty much the same thing, but in reverse. I want to end up with an r sine theta and an r cosine theta. Because if I get an r cosine theta, I'm going to put an x in its place. And if I get an r sine theta, I'm going to put a y in its place. So when I look at something like this, if I multiply both sides by what's on bottom, then I get r times sine plus 3r, can't talk and write at the same time, I write the wrong thing. When I distribute the r, I get r times sine and I get 3r times cosine, and then that cancels out, so I've got 2. Oh, there's an r times sine, well that's really y. And there's an r times cosine, that's really x. So when I replace the terms with rectangular variables, then that really becomes y plus 3x equals 2, and then you just solve to get y by itself, so subtract the 3x. So that equation in polar form is the same, would give me the exact same graph as that equation in rectangular form. So looking through these real quick to see if there's anything weird going on. In this one, we've got r, and I multiply both sides by 1 plus 2 cosine theta. So that becomes r plus 2r cosine theta. Oh, there's an r cosine theta. I can replace that with an x. But I've got a problem because I've still got an r in there, and I don't need an r in there. I need an x and a y, not r. So gosh, if only there was some formula that I could use that told me how x and y and r all relate to each other. Oh wait, there was the Pythagorean theorem. So in place of that r, remember our triangle up there? We had x, y, and r. If r is equal to the square root of x squared plus y squared, then in place of that r, I can put that. And then the rest of this is just algebra, because remember, my goal is to get y by itself. So I squared both sides, and then I distributed the 2 minus 2x, did all that, subtracted x squared from both sides, and then did the square root, and there's your equation in rectangular form. Okay, I'm going to stop this here, and then I'll do another one on the rest of the notes if you need that.